We're going to talk about section 11.5, the binomial theorem. So we're going to be expanding binomials in this section, and in order for us to do that, we need to start with something called the binomial coefficient. It's these parentheses with two numbers inside, n above r. Okay, and that's actually how we read it. So when you see, and you can see a couple examples down below of what those look like. So we use our factorial notation. So when we have parentheses n above r, that means we're going to do n factorial on top. In the denominator, we've got r factorial, and then multiplied by the difference between the two. So n minus r factorial. Okay, so sometimes, and actually I'll show you guys both methods. Sometimes you guys will see this notation, NCR, instead of this, and actually your calculator has this notation in it. So I'll show you guys both. So when we have something like 6 over 2, we would set it up as 6 factorial over 2 factorial. And then in parentheses, n minus r means we're going to have 6 minus 2, parentheses, factorial. Okay, now remember that the factorials mean we have 6 times 5 times 4 times 3 times 2 times 1. Okay, so it's always the product of that number and every integer below it up until 1. 2 factorial is 2 times 1. This is 4 factorial, so it's 4, 3, 2, 1. Okay, so we can cancel out some common factors. I'm left with 30 divided by 2, which is 15. Okay, so I would expect you guys on a quiz to be able to set up the initial factorial notation, just like how we have up here. And also to be able to find the final answer. Again, you can find it just by multiplying out like we did here. Or you can use your calculator. So I am going to show you guys how to do that in 2 different ways. So the first way is to just type in what we see here, and I have to show you guys where the exclamation point is. So if let's first put my numerator in parentheses. So I have 6, and I need the exclamation point. If we hit the math button and scoot over to the right until you hit probability, PRB, notice number 4 is that exclamation. Okay, so now I can divide by, so the bottom is 2 factorial and then 4 factorial. So I'm going to do the same thing. I don't think you need the times in between, but I put it in there. It is really important that you guys put parentheses around that whole denominator and the numerator too, okay? Because it's dividing the top by the bottom, okay? And notice you end up with the same answer, okay? Now the third method is using our other notation, NCR. So if I use that notation, the n comes first, so it would be 6C2. Okay, so 6C2, the way that we type it into the calculator is you have to type the 6 first, and then we're going to go back into that same math menu and probability. And notice you have NCR. I'm going to click that. And now I put the 2 in because you want to make sure that the 6 is on the same side as the n and the 2 is on the same side as the r, kind of like how you have it here. This is how you type it in. And notice you type it in and you get the same answer. Okay, so I'm okay with any of these methods. This one might be the fastest. However, you guys do need to be able to plug into the binomial coefficient notation over here. Let's say on a quiz, this might be a question. Okay, so doing our second one, let's do both methods by hand and then in the calculator. So let's say we've got 9 factorial over 3 factorial and then 9 minus 3 factorial. Okay, so 987 all the way. And then 654, 3, 2, 1. Most of the time you're gonna find that it's really fast like this. So now I have 9 times 8 times 7 up top, divided by 6, and we get 84. Okay, now if I wanted to do NCR, so it'd be 9C3. Okay, we're gonna do 9, math, probability, NCR, 3, and you get the exact same answer. Okay, so both of those are acceptable. Now we're gonna be using this notation later on, which is why we introduced it right now. Okay, so the whole point of this section is to be able to expand binomials. Now what does that mean? That means if you have a binomial, that's 2 terms, raised to a power, how does it simplify? Now most of the time, well, here's pretty straightforward. A plus b times itself, just including itself once, is just a plus b. Okay, well, what does it mean to square something? It means to multiply by itself. Now I'm gonna do the work off to the side. A plus b, a plus b, and we would need to FOIL. So I'm gonna FOIL first, outside, inside, last. A squared plus ab plus another ab plus b squared. So that leaves me with a squared plus 2ab plus b squared. Okay, now what does it mean to have that raised to the 3rd power? Well, I'm gonna erase what's going on over here because we don't really need it. And let's repeat the process. So we have a plus b times a plus b times a plus b. Now you might notice that there's going to be a lot of foiling. We would have to FOIL these 2 first. So you've got a squared plus 2ab plus b squared, and then distribute again. Now that's a lot of work, okay? And obviously as we get into even larger powers, no one's going to want to do all of that distributing. There's a lot of room for error, and it's really just not an efficient way to go about it. So I'm going to write out our next few binomials just because I already have it worked out, and we're going to look at some patterns over here. So I've got a cubed Okay, so these are the first 5 binomials expanded out. And so we're going to look at some of those patterns here, okay? So the first term, notice we've got an a here. The a exponents decrease by 1 in each successive term, okay? So for example, I've got a squared, I've got a to the first, okay? Here I've got a cubed, a squared, a to the first. a to the fourth, a to the third, a squared, a to the first, okay? Really, that last term is a to the 0. That's why it's not there. A to the fifth, a to the fourth, a to the third, a to the second, a to the first, a to the 0. Okay, so our a terms as the degree is going up, with each successive term, so one term after the next, the degree goes down. Now, if you notice the b's, so I have b to the 0 here because there are no b's, and then b to the first. Okay, b to the 0, b to the first, b to the second. B to the 0, B to the first, second, third. 0, 1, 2, 3, 4. 0, B's, remember. 1, 2, 3, 4, 5. So the B's are going up, okay? The sum of the exponents in any single term is n. So n is the power, right? So n was my power. Notice the power of this term, the degree is 1, the power is 1. Here, the power is 2. If I add up the degrees here, 1 plus 1 is 2, and then I have 2. Let's jump down here. 4 and 1 is 5. 3 and 2 is 5. 2 and 3 is 5. 1 and 4 is 5. 5, 5. So in any single term, the total power is going to be 5 when we add up the exponents. And the total number of terms will be 1 more than n. So for example, I have n is 5. I have 1, 2, 3, 4, 5, 6 terms. N is 4. I have 1, 2, 3, 4, 5 terms. It's always 1 more. Okay. Now, with our binomial expansion, the binomial theorem is basically like a formula that allows us to expand any polynomial just by looking at some of the numbers in the polynomial and doing a little bit of work, okay? So let's say I have a plus b to the n power. You'll notice I have the binomial coefficient in the front. So you're going to start with n, which is your power, over 0, over 1, over 2, all the way up until you get to itself, okay? And you'll notice the exponents. So we're starting with a to the n, so a to the n power is the first power, and then it keeps going down by 1 each time, okay? It looks a little more confusing here than when we actually do it, but you'll get the hang of it. So with our b's, this first one doesn't have any b's, b to the first, b to the second, b to the third. So the second part goes up in degree every time, okay? Now this is a more succinct way to write it. I generally will not, you guys aren't plugging this into your calculator or anything like that. You're gonna be expanding by hand, mostly using something like this. Okay, so I'm gonna show you a couple examples of what this looks like, and then you'll be able to try it in your homework later. Okay, so for example, we've got x plus 2 to the 4th power, okay? So let's first of all write our variables down. So I know that a is going to be my first part in the parentheses. So my a is actually x. Okay. The b is 2. And the n is 4. Okay. So if we're writing out the expansion here, we're going to start with parentheses 4 is 0, because it's n over 0. Okay. And then we've got a to the n power. So it's a to the 4th. Okay, so that's my first term. I just matched it up over here. Next, I've got n over 1. Okay, and then it's going to be a to the n minus 1 power. So it's going to be, oh, actually I shouldn't have put the a in. That should actually be x. My mistake. So we've got, there we go. So you're going to have x to the 3rd power. Okay. And then b, remember, is 2. So I'm just going to put that over here. Okay. And then I'm ready to move to the next term. I've got 4, oh, don't need the bar over. I'm used to doing fractions here. So 4 over 2, and then we're gonna have x squared. It's 1 degree less for the x, 1 degree more for the b. So we're gonna have 2 to the second power, okay? Next I've got 4 over 3, x to the third. Ooh, that's a mistake. We're decreasing our x's. So notice we had x to the fourth, third squared, and then to the first. You could write that in if you want. 2 cubed. And then finally our last term. Okay, x to the 0 means we don't have any. We can simplify that later. And then 2 to the fourth. Okay, so now it's time for us to simplify. First of all, remember that these notations here, I can type into my calculator. So this one would be 4C0, 4C1, 4C2, 4C3, and then 4C4. Okay, makes it a little bit easier to type in instead of doing the whole binomial coefficient formula. So I've got 4C0, and notice I have 1, okay? So my first term is going to be 1 x to the fourth plus, okay, now we're gonna do, and I can just copy and paste, 4C1 is a 4. So I've got 4 x cubed times 2. We'll simplify in a minute. Okay. 4C2 is 6. X squared times 4. Actually, let's put 4C4 over here just in case I need the space. There we go. Okay. Next one is 4C3. Okay, which is 4. X, and then 2 to the third power is 8. And finally, 4C4. I'm going to show you something that happens. It's just 1. Okay. So we've got 1. X to the 0 cancels out. And then 2 to the fourth power is 16. Now, when I simplify all of this, I end up with x to the fourth plus 8x cubed plus 24x squared plus 32x plus 16. Okay. So while the initial setup might take a little bit of thought, simplifying is actually pretty easy, okay, because we're able to use our calculator for the coefficient, okay, and then we can just simplify from there, okay. All right, let's do another one together. In this case, my A is 2x. The B is negative y. Okay, because it's negative here, that's important. And then N is going to be 5. Okay. So we're going to start expanding here, okay? So using our formula, let's put that right up here so I've got some space. My power is 5, so I'm going to start with 5, 0. Okay, we've got our first term. Instead of having an x to the fifth like how I did before, now I'm going to have 2x to the fifth. Okay, and then we've got negative y to the 0. If it helps, write it in as being to the 0 power, starting with the b value. That way you know you have everything there. Okay, And then we've got plus. Okay. Our next one's going to be 5, 1. 2x to the 4th, negative y to the 1st. So the first power goes down by 1, the second one goes up by 1. And then we keep going. 5, 2, 2x to the 3rd, negative y squared. Okay, that power went down by 1, this power went up by 1. Plus 5, 3, 2x to the 2nd, negative y to the 3rd. First part went down by 1, second variable went up by 1. Keep going. 5, 4, 2x to the 1st, negative y to the 4th. And then finally our last term, 5, 5, 2x to the 0, negative y to the 5th. Okay. So our next step, I think it's faster to do the coefficients, just like how we did over here with the NCR. So I'm going to do 5C0. Okay, and notice we have 1. And I think to keep this as neat and organized as possible, I'm just going to put the coefficient in the front. So we've got 1. Okay. Next one, 5C1 is 5. Okay. 5C2 is 10. 5C3 is also 10. Okay, these last ones I'll just do off camera. 5C4 is 5. And then 5C5 is 1. Okay, so at least I have the coefficients. Now I'm ready to simplify. Okay, so it's important when you have a number raised to a power. See how I have 2x to the 5th? It's not just x to the 5th. You have to raise the coefficient to the 5th power as well. So if I do 2 to the 5th power, you'll notice I get 32. Okay, so what that gives me here is 32 x to the 5th. That's just this part over here. Anything to the 0 power cancels out. It becomes just 1. Okay, so now I'm ready for the second portion. So I've got plus, okay, I've got 5 times 2 to the 4th is 16. Now I have x to the 4th. Okay, and then I have a negative y, because raising it to the first power keeps it negative. Okay, our next one, I have 10 times 2 to the 3rd power. If I type that into my calculator, I see that it's 8x cubed. Now negative squared becomes positive, so now I have y squared. Okay, keep going. I've got 10. 2x quantity squared is 4x squared. Negative y times itself 3 times is going to stay negative and keep the exponent. Plus, now I have 5, we'll move down here, times 2x times y to the 4th. Again, raising a negative to an even power makes it positive. And finally, 1 times 1, and then we have negative y to the 5th. Okay, so if I want to write out my final answer, I'm ready to just multiply out each individual portion. I've got 32x to the 5th. Notice I have a negative here, so it's going to be minus 5 times 16 is 80. X to the 4th, y. I've got another 80. X to the 3rd, y squared. Here I've got minus 40. X squared, y cubed, plus 10, x, y to the 4th, and then finally minus y to the 5th. So one of the things I want you guys to notice happens is when you have a minus sign in here, it actually is going to alternate all of your signs. So we want positive, negative, positive, negative, positive, negative. Okay, so you can actually save that until the end if it's a trick that you remember, or if you just do the work like we did over here, you should have that correct answer. Okay. Well, what if we're looking for an individual term? Okay, so for example, I'm looking for the 7th term of a sequence. There's actually a formula for us to be able to find that. So the r plus 1st term of the expansion of this binomial looks like this. Okay, so let's say we're looking for the 7th term. I would use r equals 6 in the formula. Okay, so for example, let's do this one together. So we're looking for the 4th term in this expansion. That means I want to use r equals 3. Okay, and n is equal to 7. We can write all the same information. So remember that the a value is this portion. The b value is the second part. N is your power. Okay, so if I'm using this formula, I'm going to have n over r. So I've got 7 over 3 in this case.